Hey everyone, my name is Pandan Barve. I also go by Martian and I will be developing 8 math activities for the Sugar desktop environment under the GSoC 2024 program. So I'll just introduce my project in a brief. So what activities are? These are like you have applications for Android, right? You have programs for Windows. Similarly, you have these activities which are like executables on the Sugar desktop environment. So I'll be developing 8 math related games and activities for the Sugar desktop environment. The first one which I've worked on, it's the river crossing activity. We all know the popular puzzle where you have a goat, cabbage and a wolf. You are on a ferry, you have to carry them across, you have to come back and all that good stuff. What I'm planning to do is adding more levels with more characters that you can have, like instead of the goat, cabbage and wolf, maybe you can have more people with you have to carry across, and it can get more complicated like that. So that's what I'm working on. The next activity which also I'm currently working on is the nim game. You might have heard about it. It's actually quite famous. You have multiple rows of objects, any object, and you can pick them up, and what happens is the last person to pick up an object basically wins the game. So I'm currently working upon this and I'm working on implementing the computer AI for this. I'll also be working on Lewis Carroll's game of logic. Oh, this activity is just the bane of my existence. This is so difficult to explain. We will talk in detail about this when I get around to working on it. So for now, let's just talk about the candy game. This is a very simple game. You act like a teacher. There are children around a round table, and whenever you blow a whistle or whenever you click the next step button, in our case, the children will give half of their candies to their right neighbor, and we simply just repeat this process until all children have the same number of candies. This is just a mathematical explanation. This has a very interesting geometric explanation as well. I'll be incorporating all of that theory into the activity as well. Next up, we have the number guessing game. It's pretty simple. We've all heard about it. There'll actually be 2 type of options to play the game. So in option 1, it's just pretty simple. You just have to guess the number and the computer will tell you if the actual number was higher or lower, and you just have to keep guessing like that. The second option is where the computer guesses your number, and you just have to keep on saying lower, higher, and eventually the computer is supposed to actually guess your number. Next up, we have a slight demonstration of the Pascal's triangle. This is not a game. This is more of, again, just a mathematical visualization and an explanation. We'll get into more detail about this when I'm actually working on this. This is quite complicated to explain on itself. So yeah, this is for later. The 3 utilities puzzle is quite interesting. You have 3 houses, you have 3 types of utilities. For example, here we have water, electricity and gas, right? So you just have to somehow make it so that no connections overlap, no pipes overlap, but you're still able to provide connections to these 3 houses for each of these resources. And the basic point is that it's impossible. You can't really do that. In graph theory, we call this a K33 graph, a complete 3,3 bipartite graph. It's actually impossible to do this, and that's what we are trying to explain to children. This is a simple demonstration of graph theory's basic fundamental principles. Next up, we have the Latin squares activity. This one is also quite simple. You actually have a matrix like this. You have operations, and what you have to do is you have to fill in these blanks, right? So that the entire chain of operations in a row and a column result into their corresponding resultants. And when you advance into levels, you'll have more missing spaces and you'll also have missing operations as well. So, it will just slowly increase in difficulty. It has sort of like a narrative. You start out easy and then it gets more difficult progressively. And next up, we have the illusion box. This one is very interesting. This one I'm really looking forward to working on. This will basically just be a collection of all types of optical illusions. For example, here you have the Judd illusion, right? The point is, like, it looks like it's skewed towards the left, but it's actually on the center and it's messing with your mind, right? Similarly, the bulging lines illusion. These lines are perfectly straight, but they look like they are, bulging towards you. So the red lines as well in the Herring's illusion, the red lines are actually not curved at all, but they appear to be curved, right? So this activity will just be a collection of these illusions and explanations about how they work. And overall, I just try to keep it very fun, interactive, and interesting for everyone playing around with it. So that's all I'll be working on this summer. I hope you found that interesting. Thank you for your time.